the student council decides to form a subcommittee of 5 council members. So every single case you make has to have 5 people in it, right? To look at how funds raised should be spent on the students at the school, there are a total of 11 student council members, so that's your total. 5 of which are males, 6 are females. How many different ways can a subcommittee consist of? Doesn't say anything that this subcommittee has jobs or anything. So it is a permutation or a combination? Combination. Make sure your phone's away. So we need exactly 3 females. So I know I need 3 females and what? 2 males because I need 5. So I do 6C3 times 5C2, and what do you get?
No.
Which is?
200.
Someone said it, but I couldn't hear it. Okay, at least 3 females, it means 3 females or more. So we could go 3 females or 4 females or 5 females. You need supplements, so add 2 males and 1 male. So we would get 6C3 times 5C2 plus 6C4 times 5C1 plus 6C5. Now you have to watch yourself. Sometimes you could have like 5 females to make the group, but you only have 4. So you literally can't use that case. So sometimes people will call me over and they'll say, I typed it in, but it doesn't work. And you're typing in 4C5. That can't work, right? Your N has to be at least greater than or equal to your R. So if you're typing in 4C5, that's just a case that can't happen. It just means, yes, you could have 5 females, but you only had 4, so you can't have that case. So watch yourself on those ones when they error you. That would be why. What's the answer to this one?
281.
At least 1 female is a lot of cases, right? So this one I wanted, you could go 1 female, 2 females, 3, 4, 5. You could do that. You could add 1 and 2 to those cases because it's the same thing. Or we could do total minus. So I have 11 and I could choose 5 and I could minus no females, right? That's the only case that doesn't fit in at least 1 female. So 0 females and 5 males. So I could technically go 11 C5, don't have to worry about that, minus 5C5, which is what? 1? This is 1. I get what you're saying. I was like, where are you getting 1? I was like, that's not going to happen. I was like, it's 1 what? 461? Cool. Look at that. Fixed it. 461. Please erase if it's an actual test still, right? The 461, like I just did. Oh my gosh. Oh my gosh, what is going on? It's getting worse. Somehow moved off of my pen. Great. Okay. This one here says, consider a standard deck of 52 cards. How many different 5-card hands can be formed containing its cards? 5-card hands. Doesn't say anything about you having to play them in order, right? That would be the only way cards would be not a combination. At least 1 red means 1, 2, 3, 4, 5, which is a lot of cases. So I'm going to do the opposite. I'm going to do 52C5 and minus no reds. 0 red and 5 not reds. You could do all the cases. We will get the same answer, I promise. So it could be 52C5 minus 26C5. And what do you get? Whatever you got, if you did all the cases, is the same as what I'm getting. So what'd you get?
2, 5, 3, 3, 1, 8. Is that right?
That? At most, 2 kings means 2 kings or less. If you do the big case and take off the other ones, or you do all the cases, it's actually very similar in amount. So I'm just going to do it normal the way it is. So at most, 2 kings means 2 kings or less. So 2 kings or 1 king or 0 kings. In each of these cases have 5 cards. So I need to supplement with 3 not kings and 4 not kings and 5 not kings. So how many kings are there?
2,594,400.
Wow, you're giving me an answer that yes And we had 2,900,000.
594,400.
Yep. And how many kings are there in the deck?
4.
4. 4 C2
I don't know.
times, and how many are not kings? 48 C3. I wanted the answer, and everyone takes 8 years to answer it, so I thought I'd just take your answer with you and then go back. And then 4 C1 times 48 C4 plus 48 C5. Do I need the 4 C0? Do I need? Okay. Next page. Yeah.
Are you recording?
Yeah.
Good.
Thanks for a second.
Does the podcast read me right now?
No, it just only hears my voice. It just completely blocks out all the rest. It's an amazing mic. Of course it hears you.
Hey.
Jeez. All right.
What's my name?
During a Pee Wee hockey tryout, all the players met on the ice after the last practice and shook hands with each other. Algebraically determine the number of players who attended the tryouts if there are 300 handshakes in all. So how many did I give you? I gave you the total, right? So I have to have something, I know I don't know N, C what for handshakes? 2, and it equals? And they just shook handshakes, they just shook hands once. If they shook hands twice, I'd have times by 2, 3 times 3. Gets a little aggressive for shaking that many times and walking away. I don't really get it. Then we fill into the formula. N factorial over N minus 2 factorial 2 factorial equals 300. Multiply by the 2. So we get N factorial over N minus 2 factorial equals 600. N minus 1, N minus 2 factorial over N minus 2 factorial equals 600. N squared minus N minus 600 equals 0. What are the two numbers? Maybe 25 positive 24. So N equals 25 makes sense for people. N equals negative 24 people does not make sense. I circle it, I line it, it's extraneous. This is my box. And then you have to make sure you have a sentence. It says 25 players attended the tryouts, right? Make sure you have a sentence at the end that says 25 players attended the tryouts.
I think that.
Don't know why I capitalize players.
No, now I remember.
Here it says, how many arrangements of the word poppies? So the moment I get a word, I rewrite it. Poppies is 7 letters, 3 of which are repeated. Can be made using the following without restrictions. Without restrictions would be 7 factorial over 3 factorial, which is what? Thank you. It begins with a P. 1, 2, 3, 4, 5, 6, 7 divided by 3 factorial. I would have 3 P's here and then 6, 5, 4, 3, 2, 1. And what do we get here? Answers. The first 2 letters are P. The first 2 letters are P. So I'd have 3, 2. Then what? Does it say the first 2 letters have to be P and the second one doesn't have to be a P? No. So I could go to 5, 4, 3, 2, 1. However, on your assignment, your hand-in, it does say begins with 2, only 2, or only 3 S's. If it says only 2, then you're right. You would have to go 3, 2, 4, 4, 3, 2, 1. Because you'd have to put a 4 here to make sure that this one isn't an S. Then you could bring the S back, right? So it'd be 4, 4, 3, 2, 1. So watch that on your hand-in. This would end up can't be a P, let's say, if it said only starts with only 2 P's. Then it'd be P, P, not a P. P could come back. So it'd be 4, 4, 3, 2, 1, right? This one didn't say that. So it's 5, 4, 3, 2, 1. And what do we get? 120? That makes sense because the 3 factorial will cancel. Okay, if all the p's are together, there's 3 p's, so I go 3, 2, 1, 4, 3, 2, 1 times, which is 120 again. That's all. Yeah.
That'd be such a funny numeric response. We just like one after the other. It's like 120, 120.
You get a little bit sus.
I would not be.
Okay. I really want you to
And then
get
the
sus.
next one's also 120.
If the first letter is P and the next one is not P, how many are not P's? Then 5, 4, 3, 2, 1. And then I'm done, right? What do we also have to remember to do? Divide by 3 factorial. So this would be 120 times 4, 480. Yeah? Oh, this is 3 factorial, not 3. See, I just canceled that with that, which is totally illegal in all states, territories, and provinces. If I take this 12 divided by 6, it's 2. 2 times 120 is 240, which is the answer you gave me. So
You could do 4. You could do your answer over exclamation.
divided by a 2, I get the right answer. Because I'm an idiot and didn't expect. Good call. Next one. Right. A class consists of 5 girls, 7 boys, 12 total. A committee is to be formed of 2 girls and 3 boys. Determine the number of ways the teacher can choose the committee if there are no restrictions. So girls from girls, boys from boys would be 5C2 times 7C3. Answer?
50.
Donka. And then we have Johnny, the principal's son. So we need Johnny. How do we get Johnny? Find Johnny. Choose Johnny. Johnny 9. Then we still need 2 girls. So 5C2. What is? No. Why is it? Okay, 5C2, and then we need 2 boys left. So what do we do? 6C2. Why is it a 6 and not a 7?
Johnny's already on.
Johnny's already chosen. So Johnny has to come out of the total number of boys. Johnny has to come out of how many I need to choose. What do we get? Voila. Okay, we're going to our notes. The binomial theorem. Here it is.
What is Pascal's triangle?
Pascal's triangle is to be drawn. So, the triangle is helpful for if you wanted to not use the formula, the binomial theorem formula. But we're going to use the binomial theorem formula the whole way because it helps you get the rest of the stuff. But I'll show you Pascal's triangle for fun. So Pascal decided that you can go 1, and then you can go 1, 2, 1, and then you start off with a 1 again, and then you add these ones. 1 and 2 is 3, 2 and 1 is 3, it goes between them, and then a 1. And then a 1, and then 1 and 3 is 4, 3 and 3 is 6. That one, I don't know what happened there. 3 and 1 is 4, and then a 1. And then 1, and then 1 and 4 is 5, and then 4 and 6 is 10.
It's a beautiful triangle.
And then 10, and then 5, and then 1. And these are the leading coefficients depending on when you expanded how many terms you get. If the terms themselves are just x and y. But if the terms themselves have coefficients, you have to deal with more stuff. So Pascal's triangle is lovely in theory, but the binomial theorem is actually better. The binomial theorem is on your formula sheet. I'm giving you stuff. And it says, in the expansion of x plus y to the n, written in descending powers of x, I might just print one off and then give a plastic sleeper later. Written in descending powers of x, the general term t k plus 1 n c k x n minus k y k exists. It sounds excessive, but it's actually not that bad.
Yeah, I got that.
It has to be in this form. X plus y to the n is what your binomial needs to be in. And a binomial is 2 terms to an exponent, right? Okay? So if you have a binomial, it has to be in form of x plus y to the n. If it doesn't have a plus sign, you have to change it so that it does. Then if you have this, you can use t k plus 1. Sounds harder than it actually is. N c k x to the n minus k y to the k. I say this sounds way more excessive than it is because in about 10 minutes, you'll be able to use this perfectly fine.
That makes sense. EK plus 1 equals NCK.
NCK.
Right there.
So this fits in the perms and comms unit because it uses a combination in this actual formula, right? Now, if you look at this, this is if you have to expand a binomial. So if I just expanded x plus 2 squared, most people can do that easily. I get x squared plus 2, so plus 4x plus 4. So actually, when you expand a binomial, do you see this exponent? The 2? How many terms did I get out of it? 3. You always get one more than the exponent. So your total terms always equal n plus 1. And why do I say n? Because here's n, right? So it's n plus 1. It's one more than what your exponent is. Chillax, little John Cat. We will get there. Okay. So that one, if it's to a 2, expanding that isn't so hard, right? But if it's to a 4 like this, we would cross off the 4 and we would have to go 3a minus 2 times 3a minus 2 times 3a minus 2 times 3a minus 2. And then we would have to FOIL, distribute, collect like terms, get an answer. And that's with 4 of them. What if it's 5, 6, 7, 8, 9, 10, 11? It would be crazy, right? Now, I don't disagree that the binomial theorem would still take time to find every single term. It would. However, it will take less time and a chance of less errors. Also, with the binomial theorem, they don't often ask you to find every term. They might just ask you to find the 3rd term, or the 5th term, or the 4th term. So then it's easy to find one term at a time with the binomial theorem. With expanding, you'd have to actually find the whole thing, put it in increasing powers of x, and then find the 4th term. Okay? So, this would take a while to find. How many terms is this going to give me in the end?
5.
It's going to give me 5 terms. So this is 4 plus 1, so it equals 5 terms total. So I could expand it and get all 5 terms that way. But what we're going to actually do is we're going to use the binomial theorem to find all 5 terms. If I was actually asked to find all 5. Sometimes I'm asked to find the 1st, the 3rd, the 5th, right? But say I have to find all of them. If you're somebody who writes big, you're going to want a separate sheet of paper because we're going to be doing that formula 5 times. For someone who writes decently small, you can probably fit. Okay. So I want to find term 1. I want to find term 2. I want to find term 3. I want to find term 4. And I want to find term 5. I have to use that formula, right? Now, I need to first get x, y, and n. Those will always stay the same no matter what. The only thing that changes per term is k. Why do x and y and n stay the same? Because I have to use this. X plus y to the n. Cool. X plus y to the... X plus... What's the problem? There's no plus sign. So how can I fix that? Well, I can go 3a plus -2 to the 4. So then this is actually my x. This is my y. This is my n. And that will never change. In every term, my x will be 3a. In every term, my y will be -2. And in every term, my n will be 4. It's just k that changes. So we're going to look at this formula up here. It's tk plus 1. Let's pretend I was looking for term 4. So this is tk plus 1. This is term 4. If I'm looking for term 4, what does k have to be in order to use that formula? 3. If I was looking for term 5, what would k have to be? 4. If I was looking for term 100, what would this have to be? 99 plus 1, right? So your k is always 1 less than the term you're looking for because of using just the formula. So I know my formula. I'm going to write it down here. It's t, and I'm going to leave the k out for now. T, k, I'm going to leave the box, k plus 1, because it's the only thing I don't know, right? And then n is what? 4, c, box. I don't know my k. My x is 3a to the 4 minus k. And my y is negative 2 to the k. I'm trying to get term 1. What must I add to 1 to get 1? I heard someone whisper it. They were right. 0. I have to pick a different color. So all of these are zeros. Okay, I picked blue. For term 2, what's the only thing that's going to change? Those blues are going to be what? 1s. For term 3, the blues are going to be 2s. Term 4, 3s. Term 5, 4s. Right? That's the only thing that's going to change. Your n never changes, your x and your y never change. So, let's figure out what term 1 is. Term 1 equals, what's 4 choose nothing? 1. Now this is the problem. Here is where the absolute most errors happen. At this very next moment. What's 4 minus 0? It's a 4. We agree? Everyone will write 3a to the 4, which is wrong. What do you have to remember to do with that exponent? You're taught in grade 10. Exponent laws are huge in grade 10. Yes. The 4 has to go to the 3 and to the a. Do you see how you could oopsie and not do that? They will 100% have the answer to you not putting the 3 to the 4. They will. It will be there. It's often picked more than the correct one. Sad. So we want 3 to the 4, a to the 4. Anything to the power of 0 is just what? 1. So I can multiply all my coefficients. 1, 3 to the 4, and 1. What's 3 to the power of 4?
81.
81. And then I just have a to the 4. So I have term 1 done. Now I have to do term 2. And yes, this takes time. Don't get me wrong. But you expanding and collecting like terms is a high chance of making an oopsie. And like I said, they don't most often make you find all the terms. It's like they'll ask you for term 3 of this binomial, or term 7, or term 8. Okay? So if I want term 2, I'm now going to go t, what's my k if it's term 2? K equals what? 1. So now I'm going to go t2, oh my gosh, t1 plus 1, because it's k plus 1, equals n, which is 4, c, my k is 1, x is 3a to the 4 minus 1, and then negative 2 to the 1. So I get term 2, because 1 plus 1 is 2. 4c1 is 4. And then this is 4 minus 1, so this becomes a 3. So I have to go 3 cubed, a cubed. And then negative 2 to the 1 is negative 2. So term 2 is 4. And then 27a cubed. And then negative 2. And some people will try and leave it like this. You can't. You have to put all the coefficients together. So this, and this, multiply them. Negative 2, 16a cubed. Right? So now we have term 2. Term 3, yeah, sorry.
Do we need to show all the steps, or we jump from the top down to the bottom?
You could. I wouldn't skip one of the middles because people who go from the top down to the bottom often forget the 3 cubed. Yeah. So I would do one of the 2 steps in the middle. So term 3, k equals 2. So now I have T2 plus 1 equals 4C2, 3A to the 4 minus 2, negative 2 to the 2. When you raise a negative to an even exponent, what happens to your negative sign? It goes positive. So we're using those grade 10 exponent laws that basically didn't exist in grade 11. So lots of grade 10 is used. A lot of grade 10 is used in grade 12. Four C2 is 6. And then we get 3 squared, which is 9, A squared, and then times 4. So you can skip that middle step in there, right? But I would for sure at least show this one. And then we get 216 again. Term 4, k equals 3. So I get T3 plus 1 equals 4C3, 3A to the 4 minus 3, negative 2 to the 3. So I get term 4 equals, and then 4, and then this is 3 to the 1, A to the 1, so it's just 3A, and negative 8. T4 equals negative 96A. And then term 5. What's anything to the power of 0 again? 1. So this whole thing just becomes a 1, right? I get term 5 equals 1 times 1 times 16. I'm going to draw your attention to how the Pascal's triangle fits in here. It just does this. This is all it does. Pascal's triangle gets you this, 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 this. So if you look, this is 1, 4, 6, 4, 1. If you look up here, that's this column. So something with 5 terms is always going to have 1, 4, 6, 4, 1 as its leading for the C, but you still have to use the formula for the other parts. So I don't know why memorizing the Pascal's triangle would make it faster. I guess you wouldn't have to type the C's into your calculator. That's it. That's why I knew that this was 1, 4, 4C2 is 6, and it was back to 4 and 1 is 6. So if I want to write out this expansion, I would say 3A minus 2 to the 4 equals 81, A to the 4, minus 216, A cubed, plus 216, A squared, minus 96A, plus 16. So that is that expanded, right? You've done that right before. So they could ask you to expand the whole binomial, and you'd have to do every single one sequentially. But more often than not, they do what's on the next page. We're going to look at the examples to try in the notes. Okay, I want you to try this one. I want you to find the 4th term. What does that tell me? T4. What does that tell me? k equals 3. I need way more things though. I need x, I need y, and I need n. Where do I get those from? Here. Is there a plus sign in between? Do you know that the common error is to not remember that the plus sign has to be in between, and they'll use the x and the y? So like, you know how we had 3a minus 2? They'll use 3a and 2, right? So you have to watch yourself and make sure there's that plus sign in between. So my x is actually x. My y in this case is y. And my n is 9. Before we, or 8. Sorry, before we answer this question, they can also just ask me for the total number of terms. How many terms would this expansion have? 9. Remember, if you don't remember, go back to something easier. Go back to, what if I gave myself x plus 2 squared? Well, that would give me x squared plus 4x plus 4. Oh, right, it's one more. 2, 3, right? So if you forget, go back to an easier example. 2 gets me 3. So if the exponent 2 gets me 3, then the exponent 8 gets me a total of 9 terms. So this one would royally suck if I had to do all 9 terms. But I could sequentially do every single one. I just have to do it 9 times. They don't want me to do it 9 times. They just want the 4th term. See if you can figure it out. If I need term 4, I need to do tk, so 3 plus 1 would get me term 4. And then I get n, 8, ck, which is 3, x to the 8 minus 3, y to the 3. So I always will specify off to the side what my k is, and I'll always say x, y, n. So I have all of my knowns, right? Just like you do in physics or chemistry, all your knowns, and then you can input them and not have to overthink it. What is 8c3? So we get 56, x to the 5, y to the 3. I want you guys to try 2 and 3. What's the catch on 2? There's a minus sign, so I have to make sure I put a plus in. So my x is actually 2x, and my y is, negative 5. So try those out. So I want to find the 3rd term. That means I want t3. So what's my k? 2. Because of the formula, it's tk plus 1. But I have to remember, is it one less or one more? You don't have to remember anything. You just go to your formula, right? And your formula is tk plus 1. So if I want t3, well then k has to be 2. Don't memorize anything. Just understand that formula, right? I have people like, I never remember if it's under or over, if it's 2 or 4. Don't. You just understand. It's way better to understand. If you're memorizing something, try and find a way to understand it. Because it will stay in your head better if you understand than if you just memorize it, right? Okay. We know that I can put a plus and then a minus here. So this is my x. This is my y. This is my n. How many terms would this one have? Total? 8. Because you always get one more than that n, right? So that would give me an even number. That would give me an even number of terms, correct? So would there be a middle one? No. Let's keep that in our head. That would give me an even, which wouldn't give me a middle. Okay, so I want t2 plus 1 equals 7c2, 2x to the 7 minus 2, negative 5 to the 2. Oh, it's back to that again. I don't know what I do that caused something. Okay, what's 7c2? 21. And then I get 2 to the 5, which is 32, I believe. X to the 5, and then 25, positive. What's 21 times 32 times 25? X5. Now, the next one one less 0. I really wanted to give so many zeros. Well, blame me. I can take the blame. It's fine. I probably heard you wrong. Okay, 25. 18600. X5. Oh, gosh. I'm struggling. I really need to start using my favorite computer. The old one's just not like me. Okay, find the middle term. Well, I know n is 10. So how many terms is this? So they could just literally ask you a written response question asking you about How can you, like, that's what you have to understand with the diploma. It can be justify or determine or explain. Explain how a binomial can have a middle term. What would you have to explain?
There's an odd number of terms and there's only one in the middle.
How would you get an odd number of terms?
Exponent plus 1.
Your exponent plus 1, so what would your exponent have to be? Your exponent would have to be an even. So what we'd have to say is, I can have any binomial, it doesn't matter what the binomial is, a plus b, x plus y, 76x squared plus 97x to the negative 5. Like, it doesn't matter. What matters to make a middle term is that my n has to be even, right? My exponent has to be even. Because when my exponent is even, I will always get a total number of terms, which is one more, which would make it odd. And in order to get a middle term, I would need to have an odd number of terms. You have to explain it thoroughly. You'd actually be shocked at how many of you under-explain rather than over-explain, okay? You can't explain with an example. You can't say, oh, I can get a middle term by using this binomial, x plus y to the 6, because that would get me 7 terms, and then I have a middle term. You can't do it with an example. You can give an example at the end to explain, to clarify your explanation. You can say, and this is an example of how it would work, right? So you can say, but you have to explain it saying, I have to have an exponent on my binomial that is even, because the total number of terms is always one more, which would get me an odd number of terms. Odd number of terms will get me a middle term. Therefore, I would have a middle term. An example of this could be x plus y to the 6, and then you show what the middle term would be. That would be a perfect way to explain to show what you explained, to solidify it, but you can't just give an example when it says explain. That's just one example that works. You're not explaining how it works for everything. Does that make sense? All right. So I know I have 11 terms. Some people get stuck with what they don't know which one it is. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Worst case, you do this. Yeah. Oh, I guess sure I'm erasing them. Didn't know that was happening, but it is. It's term what? 6. So the fancy way of asking for term 6. So term 6 equals 10C6. I want to have an x, a y. I always give my knowns, and k equals 5.
Not 10C5.
Yeah, I just realized that's why I had to go back and put my k equals 5, because I put the 6. So, always put your knowns, because if you don't put your knowns, you have a chance of oopsieing, right? That's why in physics your teacher is probably so extremely pushy about having all the stuff labeled and put out there so that you don't make oopsies, right? Also, it's a lot easier in science if you put all your knowns that you have to go to your formula sheet and figure out possibly which formula you need because it has all those letters, right? You narrow it down. All right. Especially in science 10 when they're like, I don't know what to do. You're like, just put down what you have, go to the formula sheet and look for, like, force or whatever. Science 10 is a lot easier in physics than physics, but that's okay. So 10C5, and then we have a to the 10 minus 5, b to the 5. What's 10C5? What do we get? 252? A5, B5. Sounds like that stuff, A535. All right. One last one that we're going to look at is how can you, they want the term with Y5. So, do we know what X is? Yeah, do we know what Y is? Do we know what N is? What's the only thing we're missing? Okay, and we're missing something. Can we put a box till we figure out what it has to be? We did it before, right? So, I forgot I still have this. So it's like this. So this is my X, this is my Y, this is my N. I don't know K, so I'm going to leave boxes. So I'm going to go T box plus 1 equals X to the 8 minus box. Whoa, Crystal. Totally omitting the C part. That happens to me every so often. You'll see it. It's real. Okay, 8C box X to the 8 minus. No. Seriously, I'm doing something. I just need to use my other computer. 8 minus box. Negative 2y to the box. So once I have the boxes in and all my info in, I say, okay, I got stuff. I need to figure out things. The thing I need to figure out is y5. I need to have a y5. 8c blah, no y. 5, no y. Oh, there's a y. What should this be in order to get the y? 5. cool thing about the boxes is they're all K's, correct? So once I find one box out, I now know all of them. Now, if it says the term number with y to the 5, what's the term number? 6, done. This one says the term, so I actually have to find the whole term. Term number is the number of the term. Term is the whole term. So if they wanted the term number, it would be T6, but they didn't ask me that. What's 8C5? Anyone? And then this is 5 to the 3, which is 125. And then negative 2, we have to remember to distribute, right? Negative 2 to the 5 is negative 32. Y5. I did it again. It's when I touch the edge of this box, it kicks out my pen. It wants me to move it. Negative 224,000 y to the 5. So that is the term. The term number would be 6. They didn't ask it. We're finishing up the next part, the other part tomorrow, which is the last 4 examples. We're going to do those tomorrow and then you're going to work. So what I'm actually going to do tonight, would you rather have half your homework tonight to work on, or would you rather just have tonight to work on the hand-in, and then you could ask me questions tomorrow when you don't know about the floor layout? I do, so it's almost done. The homework. I'll give you the homework as an option, because you could do it tonight if you want to, or you just do it tomorrow night with the other half, right? So I'll just tell you what part of the homework you can actually do. Then everyone can be happy to get everything. Because I'm not going to cross off homework, I'm just going to reiterate what you can do, because I will cross off some tomorrow, but we're just going to go for today, page 542. One is stupid. Stupid. I don't want you to expand. Oh, there we go. 4. 4AB just asks you how many terms there are, so that's a fast one.